right, let's get going. We are continuing our work in lesson 5.3, and I'm working right here with this 2 cosine squared x minus cosine x minus 1 equals 0. The first thing we're going to do is split this up into 2 factors. So I know I'm going to have 2 cosine x plus 1 times the cosine x minus 1 is equal to 0. When I split these up and make them each equal to 0 separately, 2 cosine x plus 1 equals 0. When I solve here, I get 2 cosine x equals negative 1. When I divide by 2, I get negative 1/2. Sorry, I have my funky pen again. And then I have the cosine of x minus 1 equals 0. So the cosine of x is equal to 1. Now, again, we have to be familiar with our unit circle. Where on the unit circle is the cosine of x equal to negative 1/2? Good. We know that that is 2 pi over 3. Where on the unit circle, oh, I forgot one, and 4 pi over 3. Where on the unit circle is cosine of x equal to 1? And that's going to be at 0 or 2 pi. Notice for this one we didn't have to give intervals because it told us that it has to be in between 0 and 2 pi. So we didn't have to go ahead and write that plus 2n pi or plus n pi. All right, moving on. This one's a mess, isn't it? By now, when you see that secant squared x, you probably know that you are going to plug in 3 times 1 plus tan of x, sorry, tan squared of x, minus 2 tan squared of x, minus 4, and I believe that says is equal to 0, so we'll keep that equals 0 up. I'm going to distribute 3 plus 3 tan squared x minus 2 tan squared x minus 4 is equal to 0. And I could probably add like terms here and figure some things out here. I end up getting, since these are like terms, I get tan squared x 3 and negative 4 minus 1 is equal to 0. So I know that this is saying tan of x plus 1 and tan of x minus 1 is equal to 0. Well, if I look at that, the tan of x plus 1 equals 0. The tan of x will just equal a negative 1. The tan of x minus 1 equals 0. Tan of x will equal positive 1. Well, where on the unit circle are they negative 1 and positive 1? Well, remember, tan is sine over cosine. So remember, at all those 45-degree angles, we're going to see a negative and a positive. Okay, so I have to think positive, positive, negative, negative. Sine over cosine will both be the positive ones. And then because I have negative, positive, and positive, negative, we know that they will be negative 1, where the tan lies. So we have to think about the first one that we stop at, which is here, which is pi over 4. That is going to be one of our answers, pi over 4. And remember, every half rotation, because to get around for pi is just a half rotation. So these right here are equivalent. So I don't have to put the other 7 pi over 4. We don't have to worry about all the other ones. Or, sorry, 5 pi over 4. And we know that when I hit over here and over here, let me mark that another color. Over here and over here, well, that's at 3 pi over 4. Oh, my goodness, this pen. 3 pi over 4. And I know that every half rotation is going to bring us there, because remember, when I go here, that's going to bring us there either to also for that tan of where it's equal to -1. Because remember, these are root 2 over 2 and root 2 over 2. All of them are relying on these positives and negatives. So our answer, because they didn't give us an interval, is pi over 4 plus n pi and 3 pi over 4 plus n pi. So remember, we only use these n pi's when you're actually hitting all 4 of the quadrants of the unit circle, which doesn't always happen. It happens when you have a double answer like this one, or when you have plus or minus when you take the square root. So please, please, please take note of that, and great job.